Are you struggling to compile a native library for your Android application? If you're feeling overwhelmed, you're not alone. Today, we're going to simplify the process of compiling native libraries using the Android NDK. I completely understand how confusing it can be to work with native libraries, especially when you're new to Android development. Many developers face similar challenges, and it's perfectly normal to feel lost at times. Let's dive into the specific question at hand. One user recently asked how to compile a large library of C files that relies on OpenSSL into a native library using the Android NDK. They mentioned that they had success on iOS, but found the Android documentation confusing. Sound familiar? Let's break it down together. Compiling native libraries can be tricky, especially when you need to link them with other libraries like OpenSSL. Understanding the build process and the necessary files like cmakelist.txt and android.mk is crucial for success. Stay with me, because by the end of this video, you'll have a clear roadmap to compile your library and integrate it into your Android project. Trust me, you won't want to miss this. First, the user needs to create a custom CMake file for their Android project. This file will define how to compile the native library and link it with OpenSSL. Next, the user should update their Gradle build file to include the CMake configuration. This ensures that the native library is built when the project is compiled. After setting up the CMake file and Gradle configuration, the user can build the project. This will compile the native library and generate the necessary files. Once the library is built, the user can access the native functions from their Java code. This requires creating a JNI wrapper to bridge between Java and C. Finally, the user should test the integration by calling the native functions from their Android application. This will confirm that everything is working as expected. Fun fact: did you know that the Android NDK allows you to write performance-critical portions of your app in native code? This can lead to significant performance improvements. Now, let's look at the answers provided by other users. This user suggests two main methods for building native libraries with the Android NDK, CMake and NDK build. They recommend using NDK build, which involves two key files, android.mk and application.mk. The android.mk file is used to define your library, including its source files and dependencies. The application.mk file specifies build configurations like architecture and build mode. In the android.mk file, you define the module name, include paths and source files. You can also specify shared libraries that your module depends on. The application.mk file allows you to set the target architectures for your project. Additionally, ensure your NDK path is correctly set in the local.properties file and configure your Gradle build scripts to locate your shared libraries. Finally, the user provides links for further reading on calling native methods and linking shared libraries, which can help deepen your understanding of the process. Let's take a look at an answer from another user. An alternative approach suggests that you first need to cross-compile OpenSSL for your Android platform. If you're comfortable with CMake and Gradle, you can find a complete example on GitHub. Pay close attention to the cmakelist.txt and Gradle scripts provided in that example, as they will guide you through the process. Here's a pro tip: always check the architecture of your compiled libraries. Make sure they match the architecture of the devices you're targeting. This can save you a lot of headaches down the line. And there you have it. You now have the steps to compile your native library and integrate it into your Android application. Remember, practice makes perfect. If you found this video helpful, please subscribe for more tips and tricks.